Lesson 109 is about corresponding parts and similar. Lesson 109 is about corresponding parts and similar triangles. So figures having the same shape but not necessarily the same size are called what? If you were here, I would have you answer, but I'm going to have to answer since you're not here. They are called similar. And figures having the same size and shape are congruent. Okay, it's important to understand the difference because of the questions that will be coming up. So if you look at the practice problems, A says these triangles are congruent. What is the perimeter of each? I'm going to have you guys solve that, but there is essentially, it has all the information you need. It gives you 3 different measurements. And so you just have to compare the 2 triangles and figure out what the missing side is on each one so that you can find the perimeter. The perimeter, of course, is going to be the same because they're congruent. That means they're the same size. So both of the perimeters of both of those triangles will be exactly the same. Look at B. It says the 2 triangles below are similar. What is the measure of angle A? Well, because they're similar, you just have to figure out in the second triangle which angle corresponds to A in the first triangle. Just see if you can do it, and we'll go over that in class together. We're just going to go over the rest of these in class. These are problems that you can kind of use this information to figure out. And lesson 110 is about symmetry. If you just think about different objects that you have in your house, think of a window. Windows are symmetrical. If you put a mirror down the middle of the mirror, down the middle of the window, it would reflect what's on the other side. There are some things that are not symmetrical, but that's kind of unusual, and it catches our eye because it isn't symmetrical. So an example that I use, and we've all been taught, we've been taught since we were little children not to look at people who have some sort of birth defect where they're not symmetrical. Maybe they are missing part of their arm, or one side of their face is different than the other side. It's not normal to us. It's not something that we're used to seeing. We're used to seeing people looking symmetrical, right? Your eye is located on the same side on your right as it is on the same kind of place on your face on the right as it is on your left. So that's what symmetry is. It's all around us. Think about when you were little and you made Valentines. You would fold your paper, right, in half, and this would be the fold. And you might draw a little part of a heart, and then you would unfold it, and you would have your little heart shape, because hearts are symmetrical, more symmetrical than I can draw them, obviously. Okay, so an object or figure is symmetrical if it can be divided into half, so that 2 halves are a mirror image. So we've already talked about a few examples in life. So your first question is, how many lines of symmetry does a rectangle have? So let's look at a rectangle real quick. And it's pretty easy to see that you have a line of symmetry going here. If you folded your paper in half right here, both halves look the same, don't they? And another one, if we fold it this direction, okay? The first direction, we call it folding it hot dog style. and this is hamburger style. I don't know if you've had that introduced to you, but when you're doing like different paper projects, that's what they'll call it. So my question to you is, can you do a line of symmetry this way? Because sometimes people will call that a line of symmetry. And the reality is it's not a line of symmetry, because imagine folding that paper over, you would end up with your rectangle kind of off kilter a bit, right? Your corner would come up over here, and it would not be an exact mirror image. Okay, so that is definitely not a line of symmetry. Okay, and then look at the next question, B. Which of these triangles does not appear to be symmetrical? That one's a little bit tough, so I'm going to let you guys try that one on your own, and we'll go over it in class. And then for the square, you're to draw a different line of symmetry for each square. If you're having problems with this, you can always cut out a physical square and try folding it and see how many lines of symmetry you can find. And then D, I want y'all to figure that one out on your own as well. Try to figure out what the lines are. Lesson 111 is applications using division. So in other words, we're going to have different kinds of story problems related to division. So think about what division is. It is putting equal groups, separating things into equal groups. Let's look at the first one, letter A. 100 campers are to be assigned to 3 campsites. How many campers should be assigned to each campsite so that the numbers are as balanced as possible? Okay, so this is obviously a division problem. Okay, we're taking those 100 campers and we're dividing them up into 3 different campsites. So this is campsite number 1, campsite number 2, and campsite number 3. Okay, so we want to take those 100 campers and divide them as evenly as possible into these 3 campgrounds. Well, the very first thing you notice probably is that 100 is not equally divided by 3. So that gives us a little bit of a problem. And that's really what the challenge of these problems are. You have to take into consideration what you're working with. Because normally you would say, well, 100 divided by 3, put a 3 there. 3 times 3 is 9, subtract. Okay, 33, and I know my remainder is going to be 1, so 33 and 1/3. So each campsite has 33 and 1/3 campers. Well, this camp activity is becoming rather gruesome because you can't have 1/3 of a person. Okay, 1/3 of a person will not have a good time at the campsite. So that doesn't work. So we have to think through it. All right, these are human beings. We can't divide up human beings. So what we can do is we can put 33 at 2 campsites and 34 at another. Does that add up correctly? Well, let's check. 33, 33, 34. Okay, so that's what it means by how can we make it as balanced as possible. We can put 33 at 2 and 34 at 1. So your answers for problems like this aren't going to be one number. They're going to be an explanation. I can have 33 at 2 campsites. So if I was going to write out, let's say this was my homework assignment, I would say 33 campers at 2 sites, 34 campers at 1 site. Okay, so these are kind of fun in that way. You have to figure out, it's not always going to be even. You have to use your noggin to figure out what the right solution is. Do the rest of the problem. Lesson 112 is about multiplying and dividing integers. So, in other words, we're going to be multiplying and dividing with positive and negative numbers. So, we know that when we add negative numbers, so let's say negative 3 plus negative 3, we'll get negative 6. Well, negative 3 plus negative 3 is the same thing as negative 3 times 2, right? Because multiplication is the same thing as repeated addition. So negative 3 times 2 must equal negative 6. Well, what happens when you divide negative 6 by positive 2? Well, you must get negative 3 because that's a fact family, isn't it? It's kind of easier to see multiplication and division rules of signed numbers when you look at them as fact families. So then how about negative 6 divided by negative 3? Well, that's got to be positive 2. It's part of our fact family, right? And then, of course, 2 times negative 3 will equal negative 6. So what we can glean from this is that when you have a negative times a positive number, you get your product will be negative every time. So when we're adding, right, it depends on which number's bigger and all of that stuff. But when you're multiplying and dividing, if one is positive and the other's negative, it yields a negative. Okay, when you're dividing, it's the same way. If you divide a negative by a positive, you'll get a negative. If you divide a positive by a negative, you'll get a negative. If you multiply a positive times a positive, of course you get a positive. You've been doing that all your life, right? Same with division. If you divide a positive by a positive, you get a positive. How about negative times negative? What if you have negative 2 times negative 3? Well, you get positive 6. So if the signs are the same, you get a positive. Okay, here's our examples. Whoops, I missed one. Because if you have a negative divided by a negative, you'll get a positive also. Okay. Because look at this fact family. Negative 2 times negative 3 is positive 6. Well, if you do 6 divided by negative 2, well, the signs are different. And we said when our signs are different, the answer is negative. We get negative 3. And that makes sense because negative 3 is part of our fact family. Okay, so let's do some of the examples before us. Negative 5 times 4 equals, the signs are different, so it's got to be negative 20. So what about the next one? Negative 5 times negative 4. Well, the signs are the same, so it's positive. Okay? So I'm just going to write it out with words. Signs are the same. Remember, this is only for multiplication. And division. I don't have time. I don't have space to write it out. Only for multiplication and division. If the signs are the same, the product or quotient. Remember, that's the answer to multiplication or the answer to division problem is positive. If the signs are different, the product or quotient battle of the keyboard. The product or the quotient is negative. Okay, you should make a little reminder sheet for yourself if you struggle with these so that you can know for sure that you're doing things correctly. But with practice, it will become second nature to you, just like multiplication and division is already. There are extra practice problems. On page 688 under lesson 112. I recommend doing those. If you're really confident about them, it won't take you hardly any time at all. And if you're not confident about them, it will be a way for you to get extra practice so you can become more confident by the end. Because in our lesson